This is a rational function, no?
Sir?
This is a rational function, no?
Yes, sir.
Okay, okay.
సార్ ఒకసారి ఇది చెప్పండి సార్.
ఇది ఓకే. ఏం చేశావు నువ్వు? వాట్ డిడ్ యూ డూ?
అంటే ఇది డొమైన్ కనుక్కోవడమే కదా సార్ ఎస్ ఇది.
S is a set of all real cells.
ఎస్
It
ఎక్స్
says such that right, right. No, no, not just domain. When this entire rational expression is positive, rational function. When is this positive?
అంటే అర్థం కాదు సార్ ఏంటి.
Okay, okay. So what you do? So for example, I'll give you one hint. Then you try. Okay. So okay. Let's say if someone say x minus one by x minus two. This is positive. When all it is positive?
వెన్ ఎక్స్ ఇస్ గ్రేటర్ దెన్ 2
When x is greater than two, or
ఆర్ ఎక్స్ ఈక్వల్ టు ఎక్స్
x less
లెస్
than when
దెన్
x less than one also, right? Or x less than 1, then it is positive. So now here also they are saying the same thing. Basically here 2x minus 1 is there. You have to factor this also, and you will get some factors. And you have to identify between what all segments this is positive. Okay, now do one more thing. X minus 1 by x minus 2 into x minus 3. Now when is this one positive? When is this positive now?
ఎక్స్ గ్రేటర్ దెన్ 3
X greater than 3 and
అండ్ x can't be less than 0 sir because it will be negative again.
okay, okay. So there is a simple method to find out when you are given like this. No, so for example, let's say you have something like this also x minus 1, x minus 5, and then again x minus 7, whatever, like this. Then how exactly do you find when all it is positive? Okay, for that, what we do, we'll just break this into different parts. Okay, for example, this equation, we can write it as the denominator, we can break this as 2x plus 1 into x plus 1 into x. Okay, you can break this. Now you have four parts, right? You have four parts. What? Here the denominator has got three parts, the numerator has got one part. So when all these four parts are actually positive or negative. For example, and what are these four parts? X equal to half. Here this is minus half, right? This is minus one, and this is 0, and this one is actually plus half, right? We have four parts. When x is greater than half, then all four are positive, right? Agreed.
Yes sir.
Okay, when x is greater than 0, next one is what? When x is greater than 0, all three are positive except this one. Similarly, here two are positive. So here one more positive. Beyond minus one, all are negative. Okay, you have four ones, right? All net together, they will be positive at this between less than minus one and minus half to 0 and greater than half. These are the segments. Understood?
Yes sir.
Okay, so you would have done this during your polynomials, right? For example, you are given x minus a into x minus b into x minus c, something like this, right? When a is less than b is less than c, right? What does that mean? How does the graph go? The graph goes something like this, right? This is c, this is b, this is a, right? It goes something like this. So it is positive here, it is positive here. Right. So what you do, you put A, B, C, and because there are only odd powers, you will say plus, you will say minus, you will say plus, you will say
Wavy
minus.
curve method.
Right. Because there are only odd powers. Let's say if this is square, there is square. Then what do you do?
Positive, I mean, positive sign continuous.
So you'll just ignore. When the x minus a whole square is anyway whole square. So you can actually call this, even if there is a constant, it doesn't matter. Right. So you'll just ignore a now. And you'll work with the remaining ones. Okay.
Yes, sir.
Okay, when it is greater than c, it is positive. When it is less between b and c, it is negative, and again it is positive. You will just ignore all the even powers, right? When this product is in the numerator, or it is ratio of this and something, still it doesn't matter. Just to talk about whether it is positive or negative, right?
Yes, sir.
Agreed. Okay, now we understood what exactly is this. Now tell me, what is the final answer?
Uh,
You just have to break the denominator and then tell me at what all places this expression is positive. By the way, what is the limit of this function? Limit extends to
sir,
infinity. Extends to infinity. What is the limit?
for which function, sir?
This one. 2x minus 1. This one. This one only. What is the limit when x tends to infinity?
Mm, no idea.
Okay. 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 First one is this. బ్రో చెప్పు జాయిన్ అయ్యాడు జాయిన్ అయ్యాడు ఇందాక జాయిన్ అయిపోయాడు వీడికి శ్రీకర్కే కదా ఓకే ఓకే सुहा వీడి రిషిల్ కా ఫస్ట్ సుహాస్ కా ఫస్ట్ ఓకే ఓకే ఆడికి 8:30 అన్నాలే రైట్ ఆడికి అన్న 8:30 అని ఓకే ఓకే వాడిని 8:30 కొంచెం చేద్దాం అయితే 9:30కి వీడిని పంపైతే ఓకే కూల్ కూల్
First option.
First, minus infinity to minus 3 by 2. Only one side.
Oh, okay. Third option అవ్వాలి సార్.
Third, minus 1 by 4 to 1 by 4. Huh? Wait.
One third, one minus 1/4 to 100.
Okay. So what I am getting? I am getting it is positive here, here, and here. Minus half to 0. Okay, I am getting minus half to 0 and greater than half. Okay, so we should then D and A. Correct.
Huh.
So, so they did not give the complete sets. They are saying S contains, right? S contains whichever is the subset, that is fine. Okay, understood? No.
Yes, sir.
Okay,
Then
so what is
S
our S?
contains
Our S is what? Our S is minus infinity to minus 1, minus half to 0, and greater than half. Right? That is our overall set. Now within that, if there is some subsets here that we can take. Okay.
yes, sir.
Okay. Cool. Next one. This one. This is an easy one only. Sine of log. Only thing is you should not do silly mistakes. That's it.
సార్ ఒక్కసారి చెప్పండి సార్. అంటే ఎక్కడ తప్పు చేస్తున్నా తెలియట్లేదు.
ఇది okay. Now, so under root 4 minus x square by default it should be positive, right? Because this is square root. This is
అదే
square.
వచ్చింది సార్. ఎక్స్ లెస్ దెన్ ఒక్క నిమిషం. యాక్చువల్లీ అదే ఓకే. ఓకే. అంతే వచ్చింది సార్. ఓకే.
How much you got? Minus
మైనస్
2
గా
1 only. Minus 2 to 1, no?
అంటే సైన్‌ది 1 లైస్ బిట్వీన్ -1 అండ్ 1 కదా సార్.
But how does it? No, no, no. Sine, that is range, no? Here we are talking about domain. Sine will
ఆ!
take input anything, but will give output
అందుకే
as
ఓకే.
minus 1 to 1. Don't get confused.
ఆ!
Sine will take input 100,000, whatever you want, it will take. Right? X axis is input, that is domain. Y axis is output.
సార్ ఇక్కడ ఆహ్,
This is not sine inverse. This
1
is sine.
- x
Right?
ఓకే.
So here what we have to do? 4 minus x square should be greater than 0. What that means? 1 minus x by default should be greater than 0. Right, numerator is positive and log is defined for positive. That's why 1 minus x also should be greater than 0. Why not equal to? Because it is in the denominator.
ఓకే సార్.
Right. So that's why both are strictly greater than zeros.
హ్మ్.
Okay. So that what does that mean? X square should be less than 4. And at the same time, this one also. We have this condition and this condition. Sorry. What is this? We have both conditions put together. We are getting minus 2 and 1. Okay.
ఓకే సార్.
Okay. Next one. See here. Here it is sine inverse. Now what you were doing earlier, no? Minus 1 and 1. That is applicable here.
సార్ ఇక్కడ డొమైన్ అని అన్నారు కదా సార్.
Domain of f of x.
ఓకే.
That means
ఓకే
what
సార్.
all x can take. Okay. See, what is range here? If x can be between minus 1 and 1, then again sine inverse will be anything.
యెస్ సార్.
Right? Sine inverse of x can be pi by 3, 2 pi plus pi by 3 or whatever, 4 pi plus pi by 3, whatever. So first you have to see which all x values of x are permitted in this function. That means when this log of x square by 2 to the base 2 is between minus 1 and 1.
-1, 2
1 to 2 which are open brackets, close brackets.
ఓపెన్.
No, 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 wait,
ఓకే.
wait, wait. I am getting something different. Can you check again?
1 సెకండ్. ఇది స్క్వేర్ రూట్ చేస్తే మైనస్‌ది కూడా వస్తాయి కదా!
So those silly mistakes I should not do. Okay, okay, recheck again and tell me.
ఆ!
1 second, the other guy is joining. I'll let him and tell him. Okay.
ఓకే సార్.
Hi, Suhas.
Hi,
Hello.
sir.
Hi, hi.
Hello.
Good evening. Good evening. So your timing
Good
is
evening.
slightly different, I think. Just check with Sudhir sir once.
Yes, sir. I'll check, sir.
Okay. Your functions is done, or you want to sit here, that is fine. But here we are discussing functions.
Sir, yes, sir. I'll stay.
You can sit. If you want, you can sit. Your functions is done.
No, sir.
Functions, basics of domain, codomain, one, on, two, these all things.
No, sir.
Okay, okay.
I
Okay,
know, sir.
your wish. You want to sit? That is up to you. If you can understand something, that is fine. Otherwise,
Okay, sir.
if you want, you can drop whichever way you like.
Okay, sir. I'll ask sir, sir.
Okay,
For
fine.
this. Sir, the closed minus 2 comma minus 1 union closed 1 comma 2.
Close one come perfect. Very good. Fantastic. Both close together.
Both.
Okay. Minus two, minus one union, one, two. Okay. Very good. This one. This is what? Is it domain or range?
ఇది కూడా సేమే కదా.
Here range. Range ఎంత వచ్చింది?
అదే చేస్తున్నాను. అంటే ఇప్పుడు ఈ ఎక్స్ వాల్యూ లైస్ బిట్వీన్ 1 అండ్ మైనస్ 1 కదా.
X value lies between 1 and minus 1 now. No,
ఎక్స్
no, no,
వాల్యూ కాదు.
no.
ఎక్స్ వాల్యూ కాదు సార్. సైన్ యాంగిల్ అది.
Sine value lies between 1 and minus 1. That depends on what all x can be. If x is everything, then sine value can become everything. Can become anything between minus 1 and 1. So, for example, this one, under this depends
నేను
on this also,
ఏమంటున్నా
no?
అంటే ఇది రూట్ ఓవర్ పై స్క్వేర్ బై 16 మైనస్ ఎక్స్ స్క్వేర్ లైస్ బిట్వీన్ మైనస్ పై బై 2 అండ్ పై బై 2.
Is it?
ఇంకా సైన్ కదా సార్.
Is it lying between minus pi by 2 and pi by 2?
అంటే అది నార్మల్ సైన్ వాల్యూ అంతే ఉంటుంది కదా సార్, -1 to 1.
No, 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 no. So, okay, okay. This one, for this to be pi by 2, what is x? Tell me, at what
రూట్
value of x, this root over this thing will become pi by 2?
1 second.
See, firstly, this is x square, right? X square is positive. So whatever you do, this will be less than this only.
Yes, sir.
Agreed. So you cannot make it more than pi square by 16.
No, sir.
How is it pi by 2 possible? Because pi by 2 is greater than this, no?
Yes, sir.
So root of this thing, say if x square is 0, then this will become pi by 4, right?
Yes, sir.
The highest value itself is pi by 4. No, you cannot make it pi by 2. That's what I'm trying to say.
Sir.
Got it?
Got it.
So now tell me, there is, so this root over this thing it is in certain limits. What are those limits? And within those limits, what is the value of this sign?
ఏమో సార్ రావట్లేదు.
Okay, okay. So x square, so x square can always be lesser than pi square by 16, no? Otherwise, this becomes negative, right? X square can be
Yes.
0 or it can lie between 0 to pi square by 16, right? Right, because this has to be positive, no? Root of something has to be positive, right? X square, what all it can be? X square can be 0. First of all, x square is always positive, right? And what is the highest value of this? It is pi square by 16, right? Because otherwise, if it goes bigger
Uh,
than this, then this becomes negative, right? Then what does that mean? When it is 0, this is going from root of pi square by 16 to root of 0, right? Which is nothing but it is going from pi by 4 to 0, this entire part, right?
yes, sir.
So what does that mean? This graph is actually from this to this one, 0 to not even pi. This is pi by 4. This part is pi by 4, right? So 0 to 1 by root 2. This is going from. Agreed? It is going
Okay, sir.
from 0 to 1 by root 2 only. Now 3 times of this, again 0 to 3 by root. Agreed?
The interval 3 by 4 comma 0, sir.
Interval is 0 to pi by 4. No, see this one. For just check this one, whatever is there in the square root. First of all,
Values
what
of
is
f of x.
sorry?
Answer, sir. I'm telling about the answer.
Answer is 0 to 3 by root 2.
Answer 0 to 3 by root 2. Okay.
Ah,
Okay.
agreed.
అంటే 0 to 3 by 4 అంతే కదా.
No, 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 no. 0 to 3 pi by 4. No, no, no. See, it is not 3 pi by 4. 0 to 3 sine pi by 4.
Sin by 4.
3 sine pi by 4. Sine pi by 4 is
Yes, sir.
1 by root 2.
1
Right.
by root,
So
3
it
by
is
root.
3 by root 2. Okay.
Okay.
Okay. Don't be careful. It is not pi by 4. It is sine pi by 4. It is from 3
Understood.
into 0 to 3 sine 0 to 3 sine pi by 4. Okay. Now, in this case, luckily, this is 0 and this is pi by 4, it is increasing. Let's say if it is coming from 0 to, let's say 3 pi by 4. Okay, then you cannot take the starting point and ending point and you can say that is the range, right? You understood the difference? Now it
Yes,
is
sir.
between 0 and 45 degrees. That's why we are taking starting point and ending point because we know between 0 and 45 sine is only increasing. Let's say if we are getting 0 and 120 degrees,
हाँ.
right? 0 and 120, then your highest point is 1, right? Because there is 90 degrees in between. Then you will say the range is between 0 and 1, not 0 and sine 120. Understood, no?
Okay. Understood, sir.
Understood. So here in this special case, because we know it is between 0 and pi by 4, that's why we are directly taking the endpoints. But otherwise, you have to be careful. You cannot directly take endpoints because sine is not a continuously increasing graph. Like if it is x square, it is continuously increasing. There you can take
Yes.
endpoints. But sine is not like that. So that's why sine, cos, these all things you cannot directly take. You have to see if there is some highest point in somewhere in between. If it's tan x, you can directly take because it is continuously increasing, right?
Increasing. Yes, sir.
If it is not like this, generally what you will do then? If it is not like this, if it is not continuously increasing, then what will you do?
If it's not continuous,
Not continuously increasing. These are continuous functions only. They are not continuously increasing. What otherwise you will do is, if you don't know about the function also, whether it is continuously increasing or decreasing, then what you will do? You will differentiate and then find out at those
uh,
points where this
local
thing is
maximum,
zero,
local minimum.
local maximum, local minimum, and then check whether it is increasing or decreasing. Okay, or highest point or
Okay,
lowest
sir.
point, double differentiate and all. Okay, in this case, because we know we are directly using this. Okay.
Okay, sir.
Okay, next one. This one. This is similar problem you just done previously. One second, I'm just coming.
Okay, sir.
Hmm. Am I in the done? Huh?
1 minute, sir.
Why are you doing so much? This is very, very straightforward. See, what is he asking? He's asking when is y real? That means when is y positive? That's it, right? Now you have this line. There is -1 here. There is 2 here. There is 3 here. It is positive here, negative here, positive here, negative here. That's it. So between this and here, it is positive.
Okay.
That's it. Why are you doing so
Yes,
much?
sir. Yes, sir. 1 minute.
It is so straightforward. -1 to 2 and greater than 3. Okay. Unnecessarily don't look about, don't do extra. This is a very, very basic question. Here we are asked about real values only, no? X real also, Y also real. Okay. Let's go to the next one. Okay. So this wavy curve thing, how why is it plus minus plus that you know, no? Okay. Because
Yes, sir.
individually if you do
Yes.
this, individually if you do this, overall also you'll get the same thing. Okay. Individually, this one x plus 1 is positive at these three places and negative here. X minus 3 is positive here and negative here at the remaining places, etc. etc. So we have three parts. And overall, it becomes combination of these three parts. So 3 negative, so overall negative. 2 negative, 1 positive, so overall positive, likewise. So that's why your wavy curve method also works. Okay. Now, while you apply this wavy curve for these ones, for the cases where there are squares, you have to be careful. So, for example, x plus 1 square into x plus 2. When is it positive? When is it negative? This
Sir,
one. This one. If it is something like this, when is it positive?
for post
When is
for
it positive? When is it negative?
all natural numbers.
No, you have to be careful. So, this
Oh,
is -2. It is
oh, okay.
positive here, it is
Okay.
negative here.
Okay.
Agreed?
Ah,
Understood?
understood. Okay.
Okay, this
Okay.
is a very, very basic concept. Just be clear here.
Yes,
Okay,
sir.
what about this one? X plus 1 into x plus 2. Now, when is it positive, when is it negative? Tell me.
-2, -1.
Minus 2, minus 1.
Uh,
Now,
First positive, negative, positive.
positive, negative, positive. That's it. Now you got it, no?
Actually, I know this, sir. I didn't think proper then.
Right, right. This is a very, very basic concept. Okay, when there is square, you have to be careful. Okay,
Ah,
and whether it is
it
in
is a,
numerator, denominator doesn't matter. Only thing is, if it is in denominator at x equal to 2, this is not defined. Whereas if it is in
yes,
numerator
sir.
x equal to 2, it is defined. Okay.
Wavy,
Uh,
wavy curve method, I guess.
right, right. See, if it is in it is in numerator, then curve will go like this. If it is in denominator, no, the curve will go something like this. One side like this, one side like this. You will get a vertical asymptote. Okay,
Okay, sir.
you will get a vertical asymptote. By the way, I asked you one question. Uh, which one? Which one? Which one? Somewhere I think I skipped it. This one. What is the limit of this?
1 second, sir.
Okay, so limit of this you don't need to calculate. So this is a rational function, right? What is a rational
Yes, sir.
function? Rational function is p of x
P
by
by
q of x.
Q.
Both are polynomials, okay? Both are polynomials.
Uh,
Right, right.
uh,
Both should be polynomials first. Now, what is the degree of the numerator?
1
1. What is the degree of denominator?
or 3.
Okay. When the denominator degree is greater than numerator, then by default, it is 0. Okay. By default, if it what you do when you do limits, you take the highest degree and divide everything numerator and denominator, right?
When n tends to infinity, when x tends to infinity.
X tends to infinity, this entire value will tend to 0, right? Because obviously this one grows much faster than this and this, right?
1, sir. When n tends
Okay.
to infinity
So when
value.
x tends to infinity, the limit is actually equal to 0. Okay.
So the whole function value will be 1, sir.
What? When
When
x tends to infinity,
x tends to
when
infinity.
x tends to, just check, when x tends to infinity, this limit is actually equal to 0. Just check. When limit x tends to infinity, this is actually equal to 0, not 1.
Sir, the fine x. Okay, 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 okay. On,
Understood.
sir.
Please be careful. So what you do?
Yes.
So you do 2x, and the numerator also you divide by x cube, right? Denominator also you divide by x cube, right? You divide by x cube,
X
right?
cube common is just a percent.
Right. Understood, no?
Yes, sir. Understood.
Okay. So now when the numerator and denominator are of the same order, okay, let's say if this was also 2x cube, then what is the limit? Limit is this coefficient by this coefficient, 2 by 2, which is equal to 1.
1.
If this was 3, then 3 by 2.
Then
Okay, which is
1.
equal to
Yes,
1.5.
yes. 3 by
This is
1
how
point.
this is how the rational function works. Okay, and when the denominator's highest order is greater than this one, then obviously the limit is 0. The limit when x tends to infinity is 0. So the graph, whatever you do, it will finally approach 0 on both sides. Whether it will approach from
Yes, sir.
positive or negative, whatever. Okay. Now, when this one, this, okay, so that is, and whenever there are zeros in the denominator, what does that mean? There will be vertical asymptotes. Okay. There will be vertical asymptotes.
Okay, sir.
Okay. Now, how many vertical asymptotes a graph can have?
2. Oh, 1, sir.
Why one? See, your tan x. Tan x has got
Okay, okay.
infinity vertical asymptotes, no?
Infinite. Yes, infinite,
It
infinite.
can be infinity. How many horizontal you can have?
Horizontal asymptotes. 1 second.
Just think.
Infinite.
Okay, so now you're saying horizontal asymptotes are infinite. What does that mean? Can you picture a graph? You're saying the graph will look something like this then, right?
Only one, sir. Only one.
Only one or two.
Uh, mm, uh, More than one.
How many?
Uh,
Okay.
One is a compulsory, sir. One, there'll be at least one.
No, no, no. So all graphs need not have asymptotes, horizontal asymptotes, right? So for example, y equal to x square, there is no horizontal asymptote, right? There is no vertical asymptote also. Y equal to x square. Certain graphs can have. So for
Oh,
example, 1 by x. 1 by x has got a horizontal asymptote and vertical asymptote, right? 1 by
yes,
x.
sir.
1 by x has got both. All graphs need not have. Okay. Now, if it is a rational function, generally rational function will have the same horizontal asymptote. Okay. There is only one horizontal asymptote. If it is not rational function, if you create some other creative function, then you can have at max two. One on the positive side, one on the negative side. Okay. So see, by definition, horizontal asymptote is what? When x tends to infinity, what is y going to, right? That is the definition of horizontal asymptote, no? When x tends to
Yes, sir.
infinity. Now x can tend to infinity plus infinity only once, right? So it can approach only one value, right? Agreed.
Yes, sir.
There is no approaching two values. So the graph can approach only one value. When x is tending to plus infinity, it can approach one value. When going to minus infinity, it can approach another value. If there is some absolute value or something in the graph. Otherwise, if it is a rational function, then both sides it will approach the same value. Okay?
Okay, sir. Hmm.
Understood, no? But for y, it is
Understood.
not like that. Y can be infinity multiple times. Whenever the denominator is zero, it can become infinite, right? Not defined. But for x, it is not like that. For x, x can go to infinity only once. Because for two different x's, you cannot have the same value of, you cannot have, sorry, for the same x, you cannot have two different values of y, no? Agreed.
Yes, sir.
Okay, that's why horizontal ones will be only one in case of rational functions. Otherwise, it can be it can be two max. Okay. Now
Okay, sir.
8:30 is done. I have to go to another class. Okay. You do one thing. You keep
Yes, sir.
practicing. Then we'll discuss
I'll
again.
practice, sir.
Okay. You do. You have done limits, no?
Yes, sir. I've ఇంకా ఉన్నాయి సార్ ప్రాబ్లమ్స్ కొన్ని కానీ చేస్తారు ఫంక్షన్స్
Okay.
కూడా
So
చేస్తారు.
tomorrow you want to discuss functions or limits then?
We'll discuss limits, sir. Few only few problems. Do you want me to send the problems, sir, or I'll send the problems, sir?
Which problems? Is that PYQs only or what you want?
PYQs, PYQs.
PYQs I also have. Don't worry.
No, sir. Latest year, sir. 2024, 2023, and 22.
Oh, okay. Cool. Your wish. And anyway, your Disha book they will give solutions also, no?
Yes, sir.
Okay. Cool. Whichever way you want, that is fine.
Should I
We'll do
send?
either this or that.
Should I send it, sir? Or,
Your wish. See, we are not getting after seeing the solutions also.
only few problems, sir. Not
Okay,
all.
then send those problems. Which ones you are not getting, no?
Okay, sir.
Okay, cool.
Okay, sir.
Cool. Then. Take care. Bye bye.
Bye, sir.